Problem number 1, you've got a trinomial, and it is just kind of an addition problem. You're adding 3 terms. So what we're going to do, this is the answer to some multiplication problem. So we're going to work backwards and rewrite this addition problem as a multiplication problem. So if you stare at each term, you notice, look for something they might have in common. You can divide each term by an n squared. So that's going to be my move number 1. So if I factor out an n squared, I'm going to rewrite it as n squared times n squared plus 4n minus 45. And then you always ask yourself, am I done? Is there anything else I can do? Can I go one step further? And now if you look at this trinomial, n squared plus 4n minus 45, you can factor that. And that's just an easy trinomial because the coefficient is 1. So we're going to go n squared, and it's going to be, what numbers multiply and give you a minus 45, but add and give you 4. So we're going to put an n here and an n here, because that's going to give us our n squared. And what multiplies and gives you 45, adds and gives you a 4. It's going to be a 9 and a 5. And then one of them's got to be negative. Your 5 is going to be negative. So the answer is going to be a negative 5 here and a plus 9 there. And that is what the original problem was as a multiplication problem. And if you multiply, distribute all this through, you're going to end up with that for an answer. Okay, problem number 2, same thing. So you got a trinomial. Look at each piece, see if you can factor out a common factor, a GCF, and yes, I can divide each piece by 6v. So if I divide each term by 6v, I'm going to rewrite this as a times problem. It's going to be 6v times, not 6, it's going to be 6v times v squared minus v minus 2. Okay, now you got an easy trinomial because the number in front of your v squared is just 1. So don't forget your 6v on the outside. We're going to put a v and a v. What multiplies and gives you a minus 2, but at the same time adds and gives you a minus 1? So it's got to be a 2 and a 1, and the 2 is negative and the 1 is positive, because if you add them, a negative 2 and a positive 1, they add and give you negative 1. So the order doesn't matter, but you do have to have a negative 2 and a plus 1. Okay, number 3. Okay, if you look on your foldable, this is not a trinomial. This guy is a binomial because there's 2 terms. And if you look under the tab of binomials, there's only 2 options. It's either going to be a GCF or it's a difference of squares. So a GCF, if you can divide them both by a common factor, that's the way to go. But 25 and 9 have nothing in common, but they are both perfect squares. I can take the square root of 25x squared, and I can take the square root of 9. So this is going to be a difference of squares. If you can do square roots of both, that's going to be a difference of squares. So difference of squares is going to be 5x minus 3 and a 5x plus 3. And we're done. Problem number 4. Okay, you got a trinomial right here and a trinomial right here, and they're separated with a subtract sign. So this is just the addition problem. You're combining like terms. So you can only combine ones with ones, but what you got to remember is it's a subtract. So you're subtracting everything in this group right here. So you either need to distribute the subtract to each of these guys and change their signs, or you just got to remember that you're subtracting and not adding. So for example, 8 ones minus 1. It's going to give you a total of 7. I can only do my cubes to my cubes. So I've got 3 v cubes, subtract 5 v cubes, so that's going to be a negative 2 v cubes. And then your v to the 4th, so I've got a negative 5, subtract a negative 7, so I'll subtract a negative, that's a plus. So negative 5 plus 7, I got more positives than negatives. So my answer is 7 ones, negative 2v cubes, and positive 2v to the 4th. Number 5, okay, same thing. You've got a group and a group, so in here you got a binomial, here you got a trinomial, and between the groups there's kind of an invisible multiplication sign. So this is a times problem. It's a distributive property. You need to multiply each of the 3 terms by 8v. So 8v times 6v is going to be 48v cubed. 8v times a negative 7v is going to be negative 56v squared. And 8v times negative 6 is going to be a negative 48v. And I got to turn around and do the same thing for a negative 7. So it's going to be negative 7 times 6v, negative 42v squared. Negative 7 times negative 7v, that's 49v. And negative 7 times negative 6 is positive 42. So if you multiply through, now you've got a polynomial with 1, 2, 3, 4, 5, 6 terms. So of the 6 terms, let's combine our like terms. You're going to have a total of 48v cubes. These guys right here go together. You are going to have a total, let's see, negative 56 and negative 42 is negative 98 v squareds. And then these guys go together. Your negative 48 and your plus 49. And that is going to be a positive 1v and then plus 42. Alright, problem number 6. Okay, now we're going to go totally backwards. So look where we ended up. Problem number 5. They gave us a multiplication problem when we distributed through, and we got as an answer kind of an addition problem. Problem number 6, they're giving us an addition problem, and we need to rewrite it as a multiplication problem. So on your foldable, if you've got a polynomial with 4 terms, alright, I got sidetracked. So anyway, it's a polynomial, but it's got 4 terms, and that's a huge giveaway hint. If it's got 4 terms, you're gonna have to use grouping. So grouping, you're gonna isolate 2 of them. If we just go like this guy and this guy, and you find the GCF of both those terms. So what's going to go to 20 and 35? You can divide them both by 5, and they each have x's, so I can take out x squared from both. So if I divide both those terms by 5x squared, your multiplication problem is going to become 5x squared times, divide that out, so it's going to be 4x, and divide this and you're at a minus 7. Okay, now these other 2 terms, you've got to do the same thing. Find the GCF, divide them both by 6, and it might be a 6 or it might be a negative 6, because I think we're going to have to change some signs. So if you divide them right now both by 6, a negative 24 divided by 6 is going to be a negative 4x, and a 42 divided by 6 is going to be a 7. And if you look, your signs don't quite match up, because that's 4x, but this is a negative 4x. That's a minus 7, that's a positive 7. So we should have divided each by a negative 6. So if you divide by a negative 6 instead, now negative divided by negative, that's positive. You just change the signs. So now what's common in both groups is going to be the quantity 4x minus 7. So now the 4x minus 7 is my new GCF. So my answer is going to be 4x minus 7 times times, divide them out, and what's left over is 5x squared and a minus 6. And there's your answer. Number 7, 5a squared plus 39a minus 8. Okay, it's a trinomial. Can I divide each term by 5? No. So you're kind of stuck. This is a hard trinomial. So under your foldable, this is going to be the hard one. And here's your steps. If you come across a trinomial that's got no greatest common factor, and your coefficient of your x squared is not 1, it's going to be a little more complicated, probably as tough as it gets. So here's my first move. 5 times a negative 8. I'm going to do my first times my last, and that is a negative 40. Okay, move number 2, I'm looking for two numbers that multiply and give you negative 40 but add and give you 39, and they are going to be a positive 40 and a negative 1. Okay, now I'm going to take these and I'm going to sub them in place of 39a. So I'm going to copy and paste this trinomial, so it's going to be 5a squared. But in place of 39a, I'm going to write 40a and a minus 1a, and then I'm going to bring down my negative 8. So I'm going to rewrite that trinomial as a polynomial with 4 terms. Okay, now if you got 4 terms, you just group them. So I'm going to look at all these signs, and I'm going to group now, so we've had enough practice, I'm going to group this guy with this guy, because I got one positive and one negative. And I'm going to 5a squared minus a. I'm going to divide by a. So it's going to be a times 5a minus 1. And now I'm forced to group these two. I'm forced to group 40a minus 8. And I'm going to divide these guys both by 5. No, I can't divide by 5. Got to divide by 8. So I'm going to divide them each by 8. So my GCF is 8. And that's going to be 5a minus 1. Okay, now my GCF of both these is 5a minus 1. Divide this guy by 5a minus 1. So my answer is going to be 5a minus 1 times, in my second group it's what's left over, so it's going to be a plus 8. Okay, number 8, this kind of looks like a beast too. You stare at them, and I'm going to divide each of them by, can we divide them all by 5? And they all have some x's. So I'm going to divide this guy by 5x squared. I'm going to divide this guy by 5x squared. So move number 1, let's factor out 5x squared. So let's go 5x squared times 2x squared minus 7x, and that's going to be minus 15. Then always ask yourself, are you done? Can I go one step further? And we can. So this is going to be kind of a complicated trinomial. So I need to take my first times my last. 2 times negative 15 is going to be a negative 30. So what's going to times and give me negative 30? Add and give me negative 7. And it is going to be a negative 10 and a positive 3. So I'm going to kind of put this 5x squared in my back pocket. I'm going to hold on to that till the very end. So I'm going to copy and paste the trinomial 2x squared, but in place of that 7x I am going to write a negative 10x and a plus 3x and a minus 15. Okay, now let's group them. And I'm going to group just these two guys, the first two together, and I'm going to divide them both by 2x. So you rewrite this as a times problem. It's going to be 2x times x minus 5. And if you group the second two, 3x and minus 15, divide them both by 3. So it's going to be 3 times x minus 5 Okay, now your GCF is x minus 5. So divide this guy by x minus 5, divide this guy by x minus 5. Your answer in one of the groups is going to be that x minus 5. In the other group, it's going to be 2x plus 3. And then do not forget, your very first thing, you factored out a 5x squared. Okay, number 9, this is a grouping one. I'm going to skip it because we already did a grouping one. There's 4 terms. Find the GCF of 2 of them. Okay, number 10, now you got an equation. So there's 3 types, easy, medium, hard. This one is easy because there's only an x squared. There's no x term. So if there's just an x squared but not an x, I'm just going to undo it. I'm going to solve for x. So I'm going to minus 9, minus 9. So you're going to have 4x squared on one side. 205 minus 9, 196. Okay, now divide by 4, divide by 4. You got this x squared equals 196 divided by 4. It's 49. So now you got to undo the square. So it's going to be square root. X equals a plus 7 or a minus 7. So there's going to be 2 answers. Don't forget both answers. Number 11. Okay, now this one is what we were talking about earlier. There's a k squared, but there's also a k. So if you've got a k squared and a k, you cannot do what we just barely did. But you can factor this. So I'm going to rewrite this as a multiplication problem. What times what is 21 adds and gives you 10. So it's going to be k plus 7 and k plus 3. Okay, now here's what we got. You've got something times something is 0. And here's what we know. The only way I can multiply 2 quantities and have my answer be 0 is if I times by 0. So I know either this guy's 0 or this guy's 0. One of these has to be 0. So now you ask yourself, what number can you plug into there that's going to make it end up at 0? So what number added 7 is a 0? K has to be a negative 7, or what would make this group right here 0 if k was a negative 3. So there's going to be 2 answers because it's quadratic. Your biggest exponent is 2. That tells you how many answers there's going to be. Okay, this guy's going to be the same thing, but not quite as easy. There's an x squared and there's an x, so we're going to have to factor it. But it's not as easy as 11 because your terms are kind of scattered out. So move number 1. Let's get everything on the same side. Let's move this 40 over here. So you're going to minus 40, and here's what you got. X squared plus 3x minus 40 equals 0. Okay, the 0 is actually huge. 0 is what you love. If we factor it, what multiplies gives you 40, adds and gives you 3. It's going to be 8 and 5. So a positive 8 and a negative 5. So that group times that group, your answer is 0. One of those 2 groups has to be 0. Account for both of them. The first group, if x was equal to a negative 8, that would be 0. The second group, if x was equal to 5, that would make that whole thing 0. 360. Is 360 a perfect number? Okay, 360, what you got to do is list its factors. 1 and 360. Now you make a calculator. 360 divided by 2. And there's going to be a whole bunch that go into here. If we cut it in half, half of 360 is going to be 180. I know I can divide it by 3. And that's going to be 120. You can divide it by 4. 360 divided by 4. You're at 90. You can divide it by 5. 360 has a ton of factors. But I'm going to kind of stop because here's what determines if it's a perfect number or not. So you take its factors and you add them up, except for you do not add the number itself. So if I do 180 plus 200, right there I'm already at 300, 390. So if I add the factors as they are right now, I know that it's way bigger than 360. So to be a perfect number, like the first one we talked about was 6, you add 1, 2, 3. Don't add 6, so you add up the factors 3 plus 2 plus 1, and if all the factors except for the number itself gives you that number, then it's a perfect number. Sum the even integers from 1 to 100. Okay, the even ones, that's kind of a big hint. There's two ways to go about, so let's maybe show you both. If I pair the first with the last, 2 plus 100, that's going to give me 102. And that's going to be true the entire way out. 4 plus 98, 102. So if I keep going, 6 plus 96 is 102. But the question is, how many of these 102s are there going to be? Let's see, 48 is going to be paired with 54. That's 102. And my last one, 50, is going to be paired with 52. And that is 102. So it looks like every integer is going to have a pair. So now the only question is, how many of these 102s are there? And there's going to be 25 groups of 102, because I'm going just the even integers. So that's half of them. That's 50 right there. But now if I pair them up, if I pair the smallest with the biggest, that cuts those 50 numbers right into half, because I'm going to pair them up in groups of 2. So there's only going to be 25 groups of 102. And on your calculators, do 25 times 102, and your answer is going to be 2,550. Okay, way number 2. You guys, this might even be easier. You're going to pair 0, even though it's not from 1 to 100, but you're going to pair it with 100 just because your end result, 100, is a little bit easier than 102. So you're going to pair 2 with 98. That's going to give you 100. So now the question is, how many groups of 100 are there going to be? 3 is going to be, well, 3 is odd, so it's 4, I guess. 4 is going to be with 96. That's 100. So we've got to figure out the last ones. You are going to pair 48. What are you going to pair 48? 48 is going to match up with 52. That is 100. So the only one that does not have a pair is 50. So now how many groups of 100 there are going to be if you go 0 to 100? If you pair just the evens, I think I'm going to get, I think I must have messed up somewhere. Am I getting a different answer? Because now if I have 25 groups of 100 and then this 50, oh no, I think we're alright. So how many groups of these 100 are you going to have? You're going to have 25 of them. 25 groups of 100. Last time I had 25 groups of 102, but the difference is this time, so 25 times 100 is 2500, but now this time this guy did not have anything to be paired with, so I got to add him there. So we're going to end up still at the same spot, 2550. Okay, make sure you understand this problem well, because we're going to revisit it. But we're going to revisit it with a special twist. So if you have a 4-gallon bucket and a 9-gallon bucket, can you bring back 1 gallon of water? Can you bring back 3 gallons of water? So the twist is going to be that I'm probably going to give you different size gallons buckets. So I'll give you like a 4-gallon bucket, maybe I'll give you a 10-gallon bucket. And then I'm going to ask you, with a 4-gallon bucket and a 10-gallon bucket, can you bring back 5 gallons of water? Last one, make sure you can explain how you know. So for example, like this, when factoring an easy trinomial like this guy, two numbers that times and give you 5 but add and give you -6, how do you know the signs of these? How do you know when they're both positive? How do you know when they're both negative? How do you know if you've got one of each, one plus and one minus? So look at this question right here. What kind of a trinomial would give you both of these positive? And your trinomial, if both of these are going to be positive, here's what your trinomial is going to look like. It's going to look like something like this. Every term is going to be positive. So every term positive, because a positive times a positive is a positive, and a positive add a positive is a positive. So the only way that both of these are positive, I guess the only outcome, if both those are positive, everything has to be positive. Everything. The only way a negative can creep in is if one of these is negative. So, cover all your scenarios. Make sure you can explain which one's going to be negative, how you know it's going to be negative, and we'll call it good.